Hello students, welcome to our session, and today we are going to learn about chapter number 13. The name of this chapter is electric current and its effect. Electric current and electric equipment. We all use different types of electric equipment in our daily life. You have also learned in your previous class how electric current is generated and how it is important to us. In your previous session, some topics also according our chapters. In your previous standard also there are you have chapters about the electric current, electric equipments, for example fans, AC, television. We have lots of examples of electric things and how all types of things can help us. The all types of things use electric current. Using electric current they can doing different processes and we can use them. Now the question that arises is, from where is the charge generated? The basic unit of each substance is an atom. The atom consists of positively charged proton and negatively charged electrons. Since the number of electrons and protons are equal in an atom, the atom does not carry any charge. Under special conditions, some materials tend to release electrons and become rich in positive charge, while the other gain them and become rich in negative charge. Positive and negative term. In your 6th standard, you have learned about the positive and negative terminal. On cell, you have seen on cell we have two marks are available there. Which two marks are there? There are total two marks, plus sign and minus sign. Plus sign, that means positive sign. Minus sign, that means negative sign. We can see that two signs are available. That means two terminals are used there. If we want to connect a wire with cell, then we have to connect them in their proper way. One end of wire in negative and one end of wire in positive. If we connect in them proper way, then we can blow bulb. For this we have also many activities in our 6th standard chapters about the electric equipment. Then electric circuit. The flow of electric circuit current is possible only when the charges flow or travel along a closed path. Current always flow in a path. The path along which electric current can flow is called electric circuit. Electric circuit, that means current pass in a path. This is called electric circuit. For this we have activity 13.1 available here. In activity 13.1 you can see in your textbook on page number 210 to make an electric circuit. In this activity they take a cell and then a bulb. Then connect a bulb with the two ending terminal of cell. Which two ending terminal? Plus and minus. One wire attached in minus and one minus have attached in plus. If we attach them properly, you can see that in first part A they have attached them in proper way, so the bulb will glow there. But in part B you can see there is only one wire have attached there. Other part is not attached, so the bulb is not glow there. That means the current current is not going in a path. There is not a electric circuit there. For this you need a bulb, a dry cell and insulated copper wires. If you say this activity, then you can say here, if we doing proper way this activity in proper way, if we connect the wire in both sides, that means the current will go in path. That means the electric circuit will create there. but in second part you can see the two ending points are not joined with cell, so that means the current is not going in path, so there is not electric circuit. When you connect the bulb with the cell through wires, a closed circuit is formed and the bulb starts glowing. The electrons flow through the wires from the negative terminal of the dry cell to the bulb and from there to the positive terminal of the cell. As I said, to positive terminal and negative terminal. Both terminals are used there. The circuit is made up of mainly three components. First, the cell. Second, the bulb. And third, the connecting wires. Electric circuits always used three types of components. Which three types of components? First, the cell, the bulb, and the connecting wires. The source of electrical energy or current. First, the cell, the source of the electric current, electric energy. A cell is always the source of electric current and electric energy. When we want to play with our toys, then also we keep cell in the toy. If we put cell, then the toys automatically run by their own cell. This is not possible because of the toys. This is possible because of the cells, because cell have electric current, electric power, electric energy in them. Then the bulb, the device that uses the current, bulb that use the current from the cell. The connecting wire, the conductors, that means they pass the current from one thing to another things, they are called the conductors, the conducting wires. In case you want to turn off the electric device or the bulb, you have to break the path of the electric current, which can be done simply by disconnecting of the wires. The circuit is now said to be open and no current pass through it. For example, when we want to air from the fan, then we switch on the fan, and when we do not want, we switch off the fan. That means when we switch on the fan, the current is passed. The current is passed on in a path. But when we switch off the fan, the current is not passed there. For opening and the closing of an electric circuit, we use a switch. We use switch for this movement, which has two terminals to which wires are connected as shown in figure 13.3. You can see there also in 13.3a and b. In your textbook on page number 211, you can see that switch on and switch off. The switch is on mode. The metal strip inside the switch touches both the terminal to complete the electric circuit and the bulb glows. When we switch on, that means the both terminals are working and the path and the current is going in a correct path, so we can on our object. But when we switch off our fan, the inside circuit inside it we can see the circuit which now disconnect, so the current cannot pass in path, so our object is in off condition. You can see that in a figure 13.2 in your textbook, switch in on mode and switch in off mode. In switch in on mode, you can see the both wires are connected in both terminal, which positive and negative. But in switch is off mode, you can see that the bulb is not working because the current is not passing from end to end. Now, electrical components and their symbols. Table 13.1 in your textbook, also table 13.1. In them on the next page, a few common components used in electric circuit and their symbols. We have also electric symbols. A circuit diagram is shown here in 13.3. As I said to you, in 13.3 you can see in first part switch is on, that means bulb is glow. But in B part switch is off, that means inside you can see the wire is disconnected with one terminal, but in switch on you can see the both terminal are jointed with wire. That's why we can get the object is in on condition when the switch is on, but when the switch off the wire is disconnected with only one terminal is connected, so we can get the object is in off condition. So like this, if you want to on or off the object, you can do this using electric switch. Now table 13.1. In this table, electric components and their symbols. You can see that electric components, first electric cell, then symbol. You can see also their symbol about the electric cell. Switch is on position, then battery. Then also electric bulb, switch in off condition, and wire. You can observe this table from your textbook. You have learned about an electric bulb and electric cell in classics. Like the electric bulb, the electric cell has two terminals, one positive terminal and second negative terminal. The arrangement which we use, this arrangement is called a battery of two cells. All arrangement, using this arrangement, if we will get current, this all type of arrangement is called a battery. You must have seen the batteries used in cars and inverters which have a number of cells in series. We have all seen the batteries are used in vehicles also, in inverters also. They have lots of energy in them and provide heavy current, but they are large and expensive. They are large and expensive because they have lots of number of cells are available in them. Now, resistance, conductors and insulators. Some substances allow the flow of current with more ease than others. When current flows through metals, the electrons can move through them easily. Electrons, while moving through any substance, come across imperfections within the material which cause opposition to their movement. These in the path of moving electrons in termed as resistance offered by that particular substance. All materials including metals show some level of resistance of hindrance to the flow of current. This electrons resistance, that means the some we have some types of things available. Some types of things are passed current through them, but some are not. Insulators, materials with so high resistance or conduct almost no electric current through them are called insulators. Then on page number 214, heating effect of electric current. Heating effect of electric current. We have activity 13.2 available here to show that copper wire gets heated when current passes through it. Copper wire get heated when current passes through it. For this activity, they have doing some steps. You can see that take an insulated copper wire, then remove the insulator at the ends of the wire with the help of a knife or a pair of scissors. Then they connected the wire to both sides. You will observe that the two ends of the wire becomes hot. When we read this activity, you can see there in last lines the ends of the copper wire get heated when the current passes through them. That's mean so when we pass the current through the copper, it get heated. Then we have also activity 13.3 available there to show the heating effect of current on a bulb. Insert a bulb between the cell and the conducting copper wire as shown in the figure given alongside. In this activity, they have told us to show the heating effect of current on a bulb. Using this activity, you will clear that the heating of the bulb in this activity shows the heating effect of current also on the bulb. Then we have also activity 13.4 there, to show heating effect of current on nichrome. These all activities prove that means when we pass the current to the copper, it will get heated. Then we have also the glow the bulb current on a bulb, it also heated. Then heating effect on current on nichrome. When electric current flows through a wire, a part of electrical energy is converted into heat energy and the wire gets heated, as you have seen in activity 13.2. Then like this also in 13.3 and also in 13.4. The amount of heat product produced in a wire depends on first material of a wire. When is it a material of a wire? Then thickness of the wire, length of the wire, strength of the electric current. Long and thick wire have higher resistance than small and thin wire. Thus, different materials with different length and thickness and varying current are used in different appliances depending upon their requirement. For example, in electric kettle, oven, iron, hair dryer, they all use different insulator in them, and according these they use current, use energy power. The filament of the electric bulb is made of a very thin and coiled tungsten wire which offers a large resistance. When electric current passes through it, it first gets heated to over 1500 degrees Celsius. The bulb is filled with nitrogen or argon instead of air to reduce the evaporation. That means all things which use electricity, the programming in them are different from one to another. Using this programming, they use the electric energy for doing work. So in this session we have discussed about this type of thing. First electric circuit, then electric components and other things. In our next session, we will discuss about the short circuit, overload and fuse.